Alright, today guys, we're going to be talking about vectors in three-dimensional space. On problem number 1, it says locate point B in space. Now, you're used to having the XY axis, just knowing the Cartesian plane. Right now we've added a third axis known as the Z axis that's going to add some depth to our graph. Alright? So we have the X axis here, we have the Y axis here, and now we have the Z axis. Alright? So we're going to put some points here on problem number 1. You can do it together. Alright? I want you to label this right here as your X coordinate, 7 as your Y, and the 6 represents your Z. So this right here, this is the ordered triple known as 4, 7, 6. So we're going to find this point, we're going to plot it right here on this graph. Now, what we're going to do is I'm going to highlight 4 in blue, 7 in red, and 6 in green. So right here, along the x-axis, I want you to go 1, 2, 3, 4, put a point right there. And that right there is at a 4, 0, 0. That ordered triple right there is 4, 0, 0. So I want you to label the ordered triple that represents the points that we plot. On the y-axis, 1, 2, 3, 4, 5, 6, 7. This point right here actually represents the ordered triple 0, 7, 0. Because we've got 0 in the x direction, we've got 7 units in the y direction, and we've got 0 non-zero units in the direction of z. 1, 2, 3, 4, 5, 6. In green. And what ordered triple would this represent? Correct. 0, 0, 6. So put that point right there and label those. Alright, now that I've plotted these 3 points, what we're going to do is we're going to build something that's going to give us 4, 7, 6 in this three-dimensional space. So the first thing I'd like you to do is from this 4, 0, 0, I'd like you to take your ruler and draw something straight out that's parallel. Okay? So draw something, you're going to be using the eraser here a little bit. Draw parallel to the what? Parallel to the y axis. We're drawing that straight out. So go ahead and draw that straight. Now, the next thing from this red point right here, do you guys see this line right here that I'm drawing? Well, I want to make it parallel to it. Do you guys see how I'm making it parallel? That's not parallel, is it? Right about in. That's not bad. So what I'm going to do right now is I'm going to take my eraser, erase this right here, and you guys see how this line right here is parallel to this, and this segment right here is parallel to this segment. I want you to put a point right there. Where these two intersect, go ahead and erase everything else, and we're going to call this ordered triple. How far have I gone in the x direction? I've gone 4 units from your origin. How far have I gone in the y direction? I've gone 7 units. And how far have I gone up? I've gone 0 units up. So this shape right here, everybody, this should be a parallelogram where opposite sides are parallel. Okay? Now, what I'm going to do is from 0, 7, 0, I'm going to go straight up. So I want you guys to go straight up, parallel to the z-axis. And from here, I want you to go straight over from the z-axis. This should be parallel to the y-axis. I'm going to erase these right here. I'm going to put another point. And this right here should be a rectangle. Alright, this should look like a rectangle, which is just another type of parallelogram. What's this ordered triple going to be? How far have I gone in the x direction? 0. How far have I gone in the direction of y? 7. And how far up? So that point right there represents 0, 7, 6. Okay? Alright, now I'm going to keep building our three-dimensional figure here, our rectangular prism. From right here, I want you to draw a line that's parallel to the x-axis. So this is the x-axis. I'm making it parallel to the x-axis. Then I'm going to draw going straight up my z-axis. And right here at this point, you'll notice that this is parallel to the z-axis, this is parallel to the x-axis. I'm going to erase back. We're going to call this, try to take your time, we're going to call this order triple 4, 0, 6, because this has gone 4 in the direction of the x-axis, it's gone 0 on the y-axis, and it's gone 6 units up on the z-axis. Now, everybody, this is the final thing that you're going to do. Here we go. The last thing I'm going to do is from this point, I'm going to draw a straight line that's parallel to this one, and to this one, and to this one. Then, from here, you're going to also draw a line that's parallel. Okay? From here, you're going to go straight up. Because you see where all those 3 lines intersect? They all intersect right here. Everybody, this point is your point B. I'm going to erase right here. Let's over right there. Alright? Hopefully you guys can see that this order triple right here is where 4, 7, 6 is. That's where it's located. Alright? Where did we start from? We started from this place called the origin, where you're at 0, 0, 0. This is the order triple 4, 7, 6. Now, if you wanted to write that as a vector order triple, you would say a 4, 7, 6. Alright. Yours is probably jacked up because it was a drink to Mountain Dew. No. The next thing we're going to do is we're going to find the magnitude of this. Alright? Now, I want you guys to understand, we started at 0, 0, 0, and we ended up at 4, 7, 6. So think of this as A and think of this as B. If you have to find vector A, B in 3 dimensions, you're going to have to use this formula. You're going to have to take your x-coordinate and take away your other x-coordinate. So we're going to call this one x1. We'll call this one x2. Same thing that we're doing. Now we're going to square it. Alright? We're going to do y2 minus y1. We're going to square it. We're going to add. Now we're adding our 3rd dimension, right? Which is going to be the change in your z's. So there's your y1. There's your z1. There's your y2. There's your z2. Now this is going to be really ridiculously easy because I just have to do 4 minus 0, 7 minus 0, 6 minus 0. So yes, this one's ridiculously easy. What does delta mean? You guys remember what delta means? Whenever I say write delta, what that means? That means change in, okay? Basically, you take the change in your x, you square it. Add the change in your y, square it. Add the change in your z, and square it. So yes, all we have to do is do 4 squared plus 7 squared plus 6 squared. And what will that give us? That will give us what's known as our magnitude. Okay? So we've got 16 plus 49 plus 36. When you add 16 plus 49 plus 36, it's going to get us a total of, I believe, 101. Yep, 101. Now, that's approximately equal to a 10.0 something, but if you round it to a 10.1, so it has a magnitude of a 10.1. Now, what would this vector look like in 3 dimensions? Let me show you. I'm going to do it in green so you guys can see this vector in green. We go right up here where the origin is. I'm going to make an arrow that represents a vector because it has both magnitude and direction. We're starting from the origin 0, 0, 0, and we're drawing it up going to the corner of that rectangular prism at a 4, 7, 6. So it's going from corner to what? Corner to corner. So think of it going from corner to corner in a box. That's what your vector looks like. All right, what we're going to do now, we're going to do problem number 5. We're doing problem number 5. So put problem number 5 in your journal. First thing I'm going to do on problem number 5 is I'm going to label all of my x, y, and z's in blue. x1, y1, z1 in blue. And over here I'm going to label this as my second x coordinate, my second y coordinate, and my second z coordinate in purple. We're going to use the formula that we just did. We're going to say x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Once again, this represents the change in your x, this represents the change in your y, this represents the change in your z. So now I have to be very, very, very careful. Just pretend like I'm staying right underneath this radical. We're going to plug in carefully these coordinates right here, and right here. What is my x2 coordinate? My x2 coordinate is a 7. So I've got to go 7 minus, what is my x1 coordinate? So right here, what do I actually have to plug in? I have to plug in a -4 plus, what's my y2? 2 minus, what's my y1? 5 plus, what's my z2? -9 minus, what is my z1? 8. So what I'm going to do right now, everybody, is I'm just going to highlight everything so you can see it clearly. And if you need to pause the video, you can pause it and see how everything is set up. Very important that when you do this, that you use the formula. You don't just do everything in your head. That's where people make mistakes, when they think they can just skip ahead without writing things down. What is 7 minus a -4? What's that going to end up becoming? A 7 what? 7 plus 4, so that's an 11 squared. 2 minus 5, what does that become? -3. Make sure you keep it inside of the parentheses. Very important. -9 minus 8 is what? -17 and u squared. Now everybody, your vector that you need to write for your ordered triple is 11, -3, -17. That's one of your answers. That's the ordered triple. That's one of your answers that you're asked to do. This is the change in your x. This is the change in your y. This is the change in your z. That's how you write the ordered triple. Now that's not the magnitude. What does this help you find? This helps you find the magnitude. The actual magnitude is you got to finish the problem. What is 11 squared? 121. -3 times -3 is 9. -17 times -17 is 289. You have to add all of those up together. That's all underneath a radical. All right, when we add all of these up together, we get the square root, 419, which is approximately 20.5. That right there, everybody, is the approximate value of your magnitude. So we have two answers. It asks for what is the magnitude. We have that. And it also asks, if you look at the bold, it says write the ordered triple that represents vector AB. Well, what is the ordered triple that represents vector AB? An 11, comma, -3, comma, -17. A is where we started. B is where we finished. This is the initial point. This is the terminal point. So in your journal, if you want to put, this is the initial point, write it down. This right here, you could say, is the terminal point. And I believe our video is terminating right now.